Hello everyone, welcome to this week's video about the space race. For me, there's a few key messages I want you to take away from this week. The first is that the space race is part of the wider Cold War. So outside of the context of the Cold War, the space race would make no sense. So we'll need to understand the basics of the Cold War before we fully understand the space race. Secondly, is that the very idea of the race is kind of silly, and countless revisionist attempts have altered our perspective of these events so much that it's hard to really understand what it was like back then. But from a critical perspective, there are some taken for granted assumptions about the space race that maybe get overemphasized in things like movies and documentaries. So, was it really a race? How so? Who said so? Did both the Americans and Soviets try to put humans on the moon? Was that always the goal? So, yes and no to all of those questions. We'll unpack all of this as we go. Third, I'd say that understanding the space race isn't necessarily about remembering the exact order of each event, though that can be helpful, but more so about appreciating the space race, including the Apollo program, which we'll talk about next week, is a sort of cumulative process in which experience or expertise gained in one event helps lead to the next. And then finally, um, is that while technological progress was at the core of the events of the space race, especially for our perspective, um, these were facilitated by unprecedented political and financial support that has never been seen again when it comes to space exploration. So, with that in mind, it's important to recognize that the space race is not just about rockets and spacecraft and astronauts, it's fundamentally tied to the geopolitical and social context of its time. The Cold War was a sort of continuation of World War II. At the end of the war, Europe was divided, in a sense, between the West, which had been liberated from the Nazis by the Allied powers of Canada, the United States, and Great Britain, and the East, which had been liberated by the Soviet Union, who had lost the vast majority of combatants in the conflict and were directly responsible for eliminating much of the Nazi high command when taking Berlin in April of 1945. With the Nazi threat in Europe defeated, and with the United Kingdom decimated from years of bombing campaigns, the post-World War order turned into one with two remaining global powers, the United States and the Soviet Union. Both entities realized that there was tremendous strategic value in controlling not only portions of Europe, but also regions of Southeast Asia, Africa, and Central and South America, where natural resources could be extracted for their own imperial ambitions. While initially friendly, at least while deciding the fate of Germany and much of Europe, the relationship between the Americans and the Soviets cooled, and certain ideological differences were exaggerated and communicated to their respective populations in order to gain support for the idea that their side needed to be the one to control global order for the betterment of humankind. The core ideological difference was one of political economy. The Soviet Union was an empire ruled from Russia. Its core ideology was a version of communism that had been morphed and elaborated on by subsequent leaders. By the time of the end of the Second World War, Joseph Stalin was in charge, and while state ownership of the means of production remained largely in place, democratic and representative politics, core principles of both communism and socialism, were eliminated. What was left was a distorted version of communism led by a totalitarian state, devoid of democratic accountability or press freedom. In Stalin's Soviet Union, economic activity was controlled heavily by the state with severe limitations on free exchange of goods outside of the scope of state control. To feed the Soviet Union's imperialist agenda, Stalin looked to controlling neighboring countries, namely those in Eastern Europe, in order to extract their labor, natural resources, and benefit from their geographies. It was this aspect of the Soviet Union that put it in direct conflict with post-war United States, who had similar objectives to influence, control, and extract from countries in Europe, Latin America, Africa, and Southeast Asia. Unlike the Soviet Union, the United States advocated a form of capitalism, in which the market was less regulated directly by the state or public interests, but instead by market forces and their most powerful actors. While both political economies were established to serve the interests of the state's most powerful entities, a core distinction was that the United States did not devolve into outright totalitarianism or authoritarianism. While racial and gender oppression was still prominent, a mostly free press existed in the United States and regular and free elections were held. These differences in both democratic and economic principles were highlighted as the core reasons for the Cold War. Both the United States and Soviet Union communicated with their populations through propaganda to argue that the other's economic and democratic practices were evil and opposed to freedom. However, instances in the choices of allies or selective practices by both sides reveal that ultimately the Cold War was a battle for geopolitical territorial supremacy. While the United States opposed the Soviets' lack of democracy and elimination of a free press, it was allies with, and even helped establish, fascist regimes in Chile and Spain throughout the Cold War. In the Soviet Union, while communism and public ownership of the means of production were advocated outwards, Soviet leaders regularly sought out mass amounts of personal wealth and supported the exploitation of labor inside and outside of the Soviet Union. The Cold War is sometimes explained as having been named so because no direct conflict between Russia and the United States ever took place. Some people even go so far as to say it was cold because it was not violent. This is not at all true. The Cold War was extremely bloody and violent. Through proxy wars, horrific suppressions of local democracies, and the support of dictatorships by both sides, millions of people were killed, injured, or displaced as a result of the Cold War. A vast majority of these were in Central and South America, Eastern Europe, and Southeast Asia. So what all this means is that the Cold War was a battle for geopolitical and territorial supremacy. Ultimately, the United States would be the victor as the Soviet Union collapsed in the 1990s. But all the while, between 1957 and roughly 1991, the space race unfolded as a subplot of this bloody global conflict. This brings us once again to October 4th, 1957. As we talked about last week, this was the day Russia launched an R-7 rocket carrying the first object to ever enter orbit around the Earth, Sputnik. I suppose it's worth clarifying that Sputnik is important as the first human-made object to orbit the Earth. But recall from last week, it was not the first human-made object to enter space. That was most likely a Nazi V-2 rocket. After the war, a number of rockets would have reached the 100-kilometer von Karman line that we spoke of last week, but none of them entered orbit and stayed around the Earth. They just popped through the atmosphere for a brief second and came back down. You could compare it to going into water versus actually swimming. The first human to go into water probably isn't that important, but the first human to figure out how to swim had achieved quite an accomplishment. Sputnik is as good as any event to identify as the start of the space race, and unlike some of the other events we will talk about, it was largely unexpected. Though American scientists, including former Nazi engineer Wernher von Braun, were working diligently on a plan to get to space, it was presumed by the US that the Soviets were still years away from catching up in rocket technology. Through what was later declassified as Operation Paperclip, a majority of the Nazi aerospace engineers responsible for the V-2 rocket had gone to America. Specifically, the presence of the V-2 program's lead engineer, von Braun, provided the US a sense of superiority. What they didn't know was that the Soviets had Sergei Korolev, an equally advanced thinker to von Braun when it came to rocketry. As we learned last week, the technology to get to space, such as rockets and radio communication, advanced in leaps and bounds throughout World War II. In the aftermath of the war, as both global superpowers looked to each other as competition, they were busy developing rocket technology, not primarily to reach space, but instead to reach each other. Their main goals were rockets that could deliver bombs to Washington and Moscow, respectively. After a decade of technological advancement, the idea to put technology in space as a means of showing prowess began to take hold on both sides of the so-called Iron Curtain. And after the success of Sputnik 1, the Soviets moved quickly, only months later, to launch Sputnik 2. This time, there would be a passenger aboard.
This is the story of the Russian space dog and how it was trained for its fantastic job. These movie-tone pictures are the first newsreel story of an event that has amazed the world. Limonchek or Laika and others of the same breed learn like this. They have a pressurized space kennel and they seem to like it. Now for the first picture released in the West of a Russian rocket takeoff. A small automatic camera films their reactions at a height of about 60 miles. It certainly appears that the dogs are reasonably content, even if they don't know what's coming off. The return to Earth is made by parachute, and in these training exercises, it evidently works all right. The idea is, of course, that if a dog can do it, man should be able to do it too. This dog may well be the forerunner that points the way to journeys to the moon. And who knows, further still.
November of 1957, the Soviet Union put the first living creature in space. It was a dog named Laika, who was a small terrier. The mission had a quasi-scientific objective to see if a living creature could survive in space, though again the main objective was to show technological superiority and score another propaganda win with populations both of the Soviet Union and the United States. In what would become a tragic pattern for the next 2 decades, Laika's well-being and life were not considered important in the pursuit of geopolitical superiority. While Sputnik 2's flight was a success from a rocketry standpoint, Laika suffered a horrible death as a result of suffocation and overheating. This aspect of Sputnik was not communicated publicly for decades. To this day, Laika is celebrated as a hero within the space community and even has a statue and several monuments in her honor in Russia. However, today her story reveals that the space race itself was not always a march of progress or human intelligence. None of the information gained by Soviet engineers from Sputnik 2 required Laika to be on board. Her life and those of other dogs and animals, such as cats, chimpanzees, would be sacrificed solely for geopolitical clout throughout the rest of the space race on both sides. On January 31st, 1958, the United States launched its first satellite, Explorer 1. This marked the United States' entry into the space race and quelled media narratives across the U.S. that the country was technologically inferior and bound to lose the Cold War. Explorer 1 was launched on a Juno 1 rocket, a descendant of the Jupiter C rockets which von Braun developed with the U.S. Army in the decade after the war. Explorer 1 operated for about 4 months. It was far more advanced than Sputnik 1 or 2, as it carried instruments that measured radiation in the orbital environment above Earth, as well as tracked the number of micrometeorite impacts the spacecraft faced. Both of these pieces of information would be critical to eventually sending living creatures to space and having them return alive. While its core objective was, like Sputnik 1 and 2, to express technological prowess, Explorer 1 was in many ways the first real scientific mission to space.
At Cape Canaveral, Florida, the Army's Jupiter C rocket is ready for America's second attempt to launch a space satellite. No relation to the IRBM Jupiter, this is a rebuilt Redstone, a 200-mile missile carrying, instead of a warhead, 3 stages of solid fuel booster rockets and the Explorer, a 6-foot bullet only inches across, crammed with electronic gear. 30 pounds of payload. This close-up of the United States edition of Sputnik was made at a press conference with leaders of the scientific teams, Dr. Werner von Braun, Dr. James Van Allen, and Dr. William Pickering, a 3-way collaboration between private industry, academic science, and the military. Jupiter C stands poised on its launching pad. The hours-long countdown approaches 0, a moment of enormous tension, for every missile launching is still an experiment. Any one of tens of thousands of things can go wrong, with catastrophic results. But all that can be done to assure perfection has been done. The moment is at hand. The countdown reaches 0. Some 3 minutes later, Explorer is in orbit, broadcasting to the world its coded scientific data. Cosmic ray intensity, meteor impact, solar radiation. These are the dry facts that will help carry man ever farther into the age of space.
A year later, by January 1959, the space race advanced to look beyond Earth and at the Moon. While both powers began to successfully orbit the Earth more regularly, the Soviets turned to the Moon and scored another shock propaganda win with both Luna 1 and Luna 2. The Soviets launched Luna 1 on January 2, 1959, and it became the first spacecraft to leave Earth orbit and fly past the Moon. Technically, though, Luna 1 was a failure, as its goal was to collide with the Moon. After 9 months of research, the Soviets launched Luna 2 in September of 1959. It was successful in becoming the first human-made object to contact another world when it crashed into the surface of the Moon as planned. For those in the US, this meant that the Soviets not only had rockets powerful enough to send objects beyond the orbit of the Earth, but it also implied that any location on Earth was within striking distance of the Soviet Union. While the earliest rockets capable of intercontinental travel had already been tested as early as 1957, a rocket with the power to land a payload on the moon was a real-life, very public display of the Soviets' rocket technology. Just a month later, in October 1959, the Soviet-launched Luna 3 took the first photographs of the far side of the moon. When the images taken by Luna 3 were returned to the Earth, it was the first time any humans had ever seen the far side of the moon. The images revealed that the far side of the moon was far more cratered and had many fewer mare, or dark low-lying areas in which ancient lava beds likely existed. Luna 3 was the first time that one of the superpowers took a next step in a cycle of exploration that would play itself out at other worlds such as Mars and Venus. First, the Soviets flew past at a great distance, then they impacted the moon with Luna 2, then they flew past at a closer distance for the purpose of taking images. From an engineering perspective, the next logical challenges, whether Soviet or American, would be to enter into orbit around the moon or to land softly on it. However, by late 1959, a new focus had emerged in the space race. While lunar ambitions had taken the spotlight through 58 and 59, a bold new announcement from the U.S. signaled the next steps in efforts to show technological dominance. As the 1950s came to a close, the space race is in full gear. Both the United States and the Soviet Union have put things in orbit. But rockets, satellites, and tortured animals aside, for a long time the real question was, could we put humans in space? This question had been discussed for decades with books, essays, and even early science fiction movies exploring the idea. What's interesting to think about here is how quickly this happened after humans had only developed the ability to create flying machines at all in 1903. In the span of 50 years, humanity had gone from no flight to considering the possibility of leaving Earth. In the 1950s, the question could be answered for real with increasingly powerful rockets being developed, more reliable spacecraft, and advancements in important technologies such as plastics, rubbers, lightweight metals, radio communication, and computers. Getting a human to space was now a realistic goal for both the Soviet Union and the United States. As was common throughout the space race, the U.S. would be more explicit about their plans and boldly announce their first set of astronauts. All the while, the Soviets worked a little bit more secretly in preparation to shock the world.
Ladies and gentlemen,
to confront the Soviet threat, the newly created National Aeronautics and Space Administration, NASA, has hastily put together a project to get an American into space.
today we are introducing to you and to the world 7 men who have been selected to begin training for space flight. All family men, they are here after a long and
7 test pilots are thrown to the world's media.
Please welcome our nation's Project Mercury astronauts. Perhaps we could start proceedings with a few questions. Yes, sir.
Can I ask the astronauts, do their wives and kids have anything to say about this?
Commander Shepard?
I don't have any problems at home. My family's in complete agreement.
Yes,
From a nation of 175 million, they stepped forward last week. 7 men cut of the same stone as Columbus and Magellan. But there was a difference. Rarely were history's explorers and discoverers so clearly marked in advance as men of destiny.
The Russians are trying to get there, but I think we're going to get there first.
One will be chosen to test for the first time whether a human can be shot 125 miles into space.
And one final question. Yes, sir?
Could I ask for a show of hands? How many of you are confident that you'll come back alive from outer space?
The Mercury 7 are to see the launch of the rocket that NASA hopes will take them into space. The Atlas is still undergoing trials to become America's first intercontinental missile.
Well, glad they got that one out of the way.
With the failure of the Atlas, NASA turns to its only option left, an old US Army missile called Redstone.
In April 1959, the United States announced the names of the first 7 American astronauts: Deke Slayton, Alan Shepard, Gus Grissom, Walter Schirra, Gordon Cooper, and Scott Carpenter. All the men were military jet pilots with experience flying test or experimental aircraft. While it remained unclear how or whether humans could survive for extended periods of time in space, the U.S. was confident that press conference introducing all 7 men and bold predictions for eventual human spaceflight were necessary to combat public perception that they were losing the space race. The astronauts would become known as the Mercury 7, with Mercury being the name for both the program that would send them to space as well as a small single-rider spacecraft that would be their vehicle in orbit. The plan was for the Mercury spacecraft to be put in orbit by the Atlas rocket being developed by the U.S. Air Force. The Mercury capsule was small and rudimentary by today's standards. While the pilot on board would have some control and be able to maneuver through the use of small thrusters, much of the navigational work for the capsule was done on the ground and communicated up to the pilot by radio. While the U.S. was confident that the Mercury 7 press conference and Project Mercury overall would boost confidence in their regime's capabilities, the Soviets once again shocked the world with a surprise accomplishment.
Pilot, whom the Russians have deified as the man of the century, arrives at the airport outside of Moscow for his first public appearance. Questions that have arisen in the West about the validity of his flight have no place here today, as the crowds go wild over the first man to conquer space. Major Gagarin's initial function is a long red-carpeted walk to the platform, where Khrushchev greets him. Gagarin puts party first by thanking the communists for the opportunity. Erupts with a Russian bear hug and kiss as Yuri's pictures are waved. There have been grumblings in Russia about the cost of the space program, but that is forgotten today as tens of thousands pour into Red Square to get a glimpse of their hero. He stands atop Lenin's tomb and receives their accolades. There have been many unanswered questions about the flight, but there's no question of who is #1 man in Russia today.
On April 12, 1961, Russian test pilot Yuri Gagarin entered space to become the first person to not only leave Earth, but also to orbit it. Gagarin flew in a crewed spacecraft called Vostok 1. He had no control of the flight, and much of the mission was at the mercy of the success, or not, of the Vostok K rocket. The launch and the orbital entry was a success, and Gagarin orbited the Earth exactly once over an almost 2-hour period. He returned safely after his spacecraft re-entered the atmosphere, and as he parachuted out from a spacecraft, he landed in a farmer's field in the Soviet Union, where he quickly phoned Moscow to inform them he had survived. Gagarin became a national hero and, unsurprisingly, the center of much Soviet propaganda. Sadly, Gagarin died tragically during a test flight in 1968. To this day, his historic flight is celebrated during Yuri's Night, each April 12th, by people who work in the space sector all around the world. Back in 1961, however, it was another instance of the U.S. having to react to a shock Soviet space accomplishment.
Eyes to see it all firsthand. Voices to broadcast the news. Cameras to record the facts. Hands to write it all into history. From all over the world, reporters and editors, commentators and cameramen have come to witness another of America's experiments in space, Project Mercury. All news media have had full access to the program, because in a democratic society, failures are known as well as successes. Project Mercury is a program of the National Aeronautics and Space Administration, a civilian agency of the United States responsible for space research and exploration for peaceful purposes to benefit all mankind. This experiment was designed to test a man's ability to carry out useful activities in a weightless space environment. At Cape Canaveral, Florida, the press of the world was completely briefed beforehand. An astronaut in a spacecraft was to be hurled 115 miles into space and re-enter the Earth's atmosphere, landing in the Atlantic Ocean 300 miles away. And most important, he was to actually have control of his spacecraft for a portion of his 15-minute flight. Astronaut Alan Shepard's adventure in space began early in the morning. Tank cars fueled the tall, slender Redstone launching vehicle with liquid oxygen and alcohol. Shepard was taken in this specially equipped transfer van to the launching site. Here he gets a good look at the rocket, another step in man's attempts to reach the moon and beyond. He carries his own portable cooling unit to keep him cool while outside the spacecraft. Accompanied by the astronaut's personal physician, Shepard enters the elevator, which will take him to the spacecraft. Each of the astronauts selected was an experienced test pilot and graduate engineer. The spacecraft was named Freedom 7 by the 7 astronauts, who together went through 2 years of rigorous and highly technical training. Fellow astronaut John Glenn makes a final check of the interior. Astronaut Virgil Grissom wishes Shepard good luck. Engineers removed the protective overshoes. Sensitive instruments were taped to his body to record his reactions during the flight. And now into the craft to be strapped into the special couch and begin his wait for the liftoff. The countdown takes 3 hours and 24 minutes, and Shepard takes a very active part in the exacting check of the equipment. Now the gantry moves back. The countdown goes on.
4, 3, 2, 1, 0.
Liftoff at 9:34 a.m. The trajectory is perfect. Shepard climbs higher, following a flight path that will take him 115 miles up and 300 miles downrange.
45 seconds, everything looks okay. 30 seconds, everything still looks A-okay. This is 7, fuel is go, 1.8 G, 8 PSI Kevin, and the oxygen is go. Right, good girl, okay. Cabin pressure holding at 5.5 psi. Go, 2.5 G. 2.5 G, that's my report, all A-OK. Oxygen is go, the main bus is 24. Oxygen go, main bus 24 volts. 29. Right, 65 to 5. Everything was with the trajectory.
The booster burns out at 200,000 feet, and the escape tower is jettisoned. Seconds later, the craft separates from the rocket. Shepard reports taking over the manual controls, and though he is now weightless, he reports no difficulties. Still using manual controls, he fires his deceleration rockets, after which he puts the craft into the re-entry position. He reports his parachutes open, and he is descending. At exactly 15 minutes after liftoff, Shepard is back to Earth, having experienced 5 minutes of weightless flight. Recovery Force helicopters were standing by in the impact area. Shepard emerges and is lifted into the helicopter. Pilot and spacecraft are returned to the carrier Lake Champlain. Many branches of the U.S. government assisted the space agency in this experiment. He is in high spirits and shows no sign of weariness. The astronaut stops to retrieve his space helmet and then goes below for a preliminary medical checkup. Later, Shepard is flown to Grand Bahama Island. He is met by his jubilant colleagues and medical personnel. Through intensive examination and questioning, they will determine what has been learned by this experiment in space. All knowledge gained will be made available for the benefit of the entire world. Project Mercury is only one of many steps in sending a man into space, an international effort carried out with the cooperation of many nations. From these launching pads at Cape Canaveral, more space experiments will go forth, milestones toward man's better understanding and mastery of the space environment.
On May 5, 1961, American Alan Shepard became the second person to ever enter space. While he didn't orbit the Earth as Gagarin did, his Freedom 7 spacecraft was more maneuverable than Gagarin's Vostok. This was critical as any sustained human spaceflight would need to include the ability to maneuver spacecraft in orbit. The contrast between Vostok 1 and Freedom 7 in some ways reflects much of the space race. While the Soviets achieved many firsts, all except the crewed moon landing, they did so in a rushed and hurried fashion. They were bold but often reckless in their approach. Conversely, the Americans, though still pushing the limits of technology, were more prone to both ensuring safety and having their accomplishments achieve slightly more than just a basic propaganda win. So, while Vostok 1 got to space and orbit before Project Mercury, the technical advancements of Mercury, such as in-orbit maneuvering and ground spacecraft communication, allowed the U.S. to begin to make up ground lost in the early space race. As part of Project Mercury, 5 more crewed missions were take place between 1961 and 1963, all of them with a single astronaut and all of them building, slowly but surely, upon the work of the previous mission. Back in the world of robotic spaceflight, the Americans began to catch up to the Soviets in lunar exploration when they launched Ranger 4 on April 23, 1962. Ranger 4 failed to transmit any data, but did collide with the moon, making it the first U.S. craft to impact another world. Due to failures in the onboard computer, the spacecraft could not navigate properly when it arrived at the moon. It actually ended up crashing on the far side of the moon, accidentally making Ranger 4 the first human-made object to touch the moon's far side. The first fully successful Ranger mission was Ranger 7, which transmitted close-up images of Mare Numbum as the probe descended towards the surface of the moon. Rangers 8 and 9 would also send back close-up images, providing the U.S. confidence that it could develop a more mature lunar exploration program and eventually shift the focus of human spaceflight to the moon as well. On September 12, 1962, then President of the United States John F. Kennedy made a famous speech at Rice University in Texas where he boldly stated the United States' objective to put a human on the moon by the end of the 1960s. This was not the first public announcement of the plan. The first moon speech was delivered by JFK in 1961 to the U.S. Congress. While Kennedy personally was not interested in exploring the moon, he had been convinced that this public moonshot would be politically and geopolitically advantageous. It would also see a mass investment of public tax dollars into the U.S. industrial system, and thus was strongly advocated by much of Kennedy's most powerful and wealthy industrial supporters. When it was announced, the moon goal was seen as highly political and highly controversial. In fact, the speech at Rice University was in response to waves of critique Kennedy had faced from political opponents since first announcing intentions to put a human on the moon. While the moon objective would eventually turn into the Apollo program, practically there was an intermediate step needed between the initial work of Project Mercury and any future moon missions. This was Gemini program, the so-called bridge to the moon that would carry out all of the necessary research and development needed to get an American on the surface. Throughout 1962 and 1963, the Soviets advanced their human spaceflight prowess. In August 1962, Vostok 3 and 4 became the first simultaneous space missions to orbit the Earth, and among other highlights, they communicated with one another via radio. Then, on June 16, 1963, Vostok 6 launched, carrying Valentina Tereshkova, the first woman in space. In both the United States and the Soviet Union, rampant sexism meant that women were not typically considered fit for space travel. As a result, the main objective of Tereshkova's flight, seemingly, was to confirm that a female body could handle the stresses of spaceflight. Back in the US, people such as von Braun explicitly shot down the idea of any female astronauts, arguing that they would be unfit for flight and that they would serve only to distract male counterparts. The Soviets would not send another woman to space until 1982. The first female American astronaut wouldn't launch until 1983, when Sally Ride served on board Space Shuttle Flight STS-7.
The Russians chalk up another victory in the space race as they put two manned spacecraft into orbit within 24 hours of each other. Colonel Pavel Popovich and Major Andriy Nikolaev follow in the footsteps of two other Russian astronauts, Titov and Gagarin, and thus give the Soviets 4 manned orbital flights against 2 for the United States. Within 72 hours, the first man aloft traveled more than 1 million miles, 4 times the distance to the moon, a distance it would take a jet airliner 2.5 months to fly. As Vostok 3 orbited, Vostok 4 followed on its heels, at one time within 75 miles, proving that a contact in outer space was possible. Tracking stations indicate that there is little doubt of the success of the Russian feat, that is seen as 2 years ahead of the U.S. effort. The Soviets made the most of the flight in their worldwide propaganda and televised pictures of the astronauts from outer space. Naturally, there was jubilation in Russia, and the crowds followed the progress of the new heroes in Red Square.
Back in the US, by 1964, Project Gemini was advancing. A new group of astronauts was selected, which would include 22 total individuals, 16 of which would eventually go to space as part of the program. Unlike Mercury, the Gemini capsule could seat 2 astronauts, beginning an age where crews would go to space with specified roles, in this instance pilot and command pilot. The first successful crewed Gemini mission took place on March 23, 1965, with astronauts Gus Grissom and John Young. The mission's objectives were to test the maneuverability of the Gemini capsule. As a bridge to the moon, the Gemini program was designed to launch missions that would build off of previous ones, each time advancing capabilities for human spaceflight. Overall, by the end of the program, the objective was to have achieved and mastered a number of spaceflight milestones. One of these was to conduct and develop expertise in extravehicular activity, or EVA. This is when an astronaut leaves the capsule and enters space in their spacesuit. All of these so-called spacewalks would be done while the astronaut was tethered to the craft, as untethered, free-floating EVAs wouldn't happen until the 1980s. The core value of being able to undertake EVAs was the ability to exit the craft and identify, or even fix, problems with external spacecraft hardware. Another objective of Project Gemini was to master maneuvering and docking of spacecraft in orbit. While the Soviets had flown 2 craft in orbit, there had yet to be a successful docking of spacecraft. Gemini would test this as it was considered a critical part of successfully getting humans to the moon. Finally, the plan for Gemini was also to test and observe the impacts of long-duration space travel. While humans had now been going to space and back for several years, no one had stayed much more than a day or two, and the viability of a week-long trip to the moon and back was still questioned. The Gemini astronauts would stay in space for up to a week in order to identify if radiation, a lack of gravity, or any other factor would impact their ability to function. However, once again, it was the Soviets who got there first. The previously mentioned Voskhod 2 was more than just the first time 2 people flew in space together. It was also the first time a human left their spacecraft and successfully carried out an EVA. Cosmonaut Alexei Leonov conducted a 12-minute spacewalk on March 18, 1965. The feat was bolstered by the presence of a color camera which collected images that were broadcast around the world. While the spacewalk was nominally successful, there were complications. Leonov's suit overinflated, and the rigidness of the balloon suit made it difficult for him to move around. Leonov also narrowly escaped heat exhaustion and suffocation, the same fate as Laika. On the other side of the world, the first U.S. spacewalk would be accomplished by Ed White as part of Gemini 4, where he concluded a 36-minute EVA on June 3, 1965. While the Soviets had again carried out a first, the next space race achievement would see the U.S. finally be first. However, the first docking of 2 spacecraft in orbit was far from a perfect success.
Flight, we are done.
This emergency occurred when a thruster got stuck open and they were spinning wildly. They were in trouble. When the emergency occurred, I was in Houston, and you could hear everything.
Can't seem to get any valid data here. It seems to be a pretty rough.
They were into a really horrific spin, so much so that the astronauts were beginning to feel disoriented.
We've lost considerable gas pressure. Regaining control of the space slowly in RCS 2. Roger, copy.
They were going to abort, and that was critical. They had to splash down early.
It demonstrated that Neil Armstrong was a superb pilot, a superb judge of mechanical systems. God had given it to him with both hands, and he knew how to use that skill.
So, by the mid-1960s, both the Soviet Union and the United States had begun to sort of master sending craft to the moon and putting humans in orbit around Earth. One of the next logical steps then would be to send humans to the moon. This could be the ultimate propaganda win and a show of technological superiority. Why the moon? Well, as we will see in the future, and as we saw a couple weeks ago, it's the only other planetary body that is even remotely close to Earth. Using 1960s rocket technology, it would take a crewed capsule about a week to get to the moon and back. In contrast, going to Mars would take over a year, and everything beyond Mars was certainly out of the question then. The moon is also luckily pretty easy to land on and take off from because it has no atmosphere to contend with. While an atmosphere can be helpful in allowing a craft to maneuver, it provides an additional barrier to entry as approaching spacecraft need to have a precise angle of approach. Additionally, the lack of atmosphere at the moon would allow for an easy return to Earth from the surface. As we'll see next week, the Apollo program used a simple rocket to blast off the surface of the moon. This is only possible because there is no atmospheric resistance and because the gravitational pull of the moon is not overwhelming, being 1/6 that of the Earth. So while you need a very powerful rocket to leave Earth, that's only because Earth is not only much bigger with much more gravity, it's also because there's 100 kilometers of thick atmosphere between the surface and space. As the craft flies upwards, that atmosphere acts as resistance and needs to be countered with thrust. The moon is also very visible, so for propaganda purposes this held value as well. While Mars and Venus are also visible in the night sky, they are tiny and look like nothing other than just stars. The moon, of course, is unique in its brightness and its size, and on a full moon it dominates the night sky. If someone were to get there first, and figuratively or literally plant their flag, the view of the moon could be a nightly reminder of the other side's technological superiority, or so it was hoped. By early 1966, with human spaceflight advancing quickly around Earth orbit, attention was again on the moon. On February 3, 1966, the Soviet Luna 9 became the first human-made object to achieve a soft landing on the moon. The craft landed in the Oceanus Procellarum region, where a protective shell opened to send back images which it had taken as it approached the lunar surface. While this was only one data point, Luna 9's successful landing was evidence that the surface of the moon was stable enough for a spacecraft to touch down safely and continue operating. This was also the first time that a mission would experience skidding or bouncing, in which it collided with the ground several times before coming to the rest. In the case of Luna 9, the Soviet engineers were fortunate that the craft landed with the proper side facing up. While Luna 9 was a great success, as would be Luna 13 11 months later, an ominous tragedy had just struck the Soviet program. In January of 1966, weeks before the launch of Luna 9, chief rocket designer Sergei Korolev died. Without many people knowing it, the Americans had just gained a major advantage in their pursuit of space dominance. Towards this dominance, the Americans responded to Luna 9 with their own lunar soft landing.
Surveyor was now within 1,000 miles of the moon's surface, hurtling in at 5,000 miles an hour. Within that short distance, a precise combination of brute power and finesse would have to slow it down, maintain perfect balance, and bring it in at a gentle fall.
Surveyors reported in excellent condition. All signals look good. 4,000 feet, stable. 400 feet. 200 feet. 100 feet per second. 100 feet. 100 feet. 100 feet. 13 feet per second speed. Touch. The bus piece reports touchdown.
If Surveyor had done only this, made a perfect soft landing on the first shot after traveling over 240,000 miles against overwhelming odds, it would have been a tremendous achievement, would have built the bridge for the astronauts. But it did much more, paid dividends almost unhoped for.
These pictures will be with the lens at wide-angle setting.
Cool and detached, the voice of the scientist calls out Surveyor's achievements. And so it went on. The parade of pictures, over 10,000, remarkable as a triumph of technique, yet now routine in a way, as Surveyor's camera obeyed every command, fulfilled every request. It sent back man's first close look at the mountains, the rocks and craters of the moon. It identified such landmarks as the range of mountains known to be part of the Flamsteed crater. The excellent resolution of nearby rocks and surface indentations caused by Surveyor's footpads is helping scientists determine detailed surface physical properties. But most important is the fact that Surveyor did land on the moon and worked.
By August of 1967, the U.S. was wrapping up what it had called its Lunar Orbiter Program. We don't talk much about these, but through 1966 and 1967, the U.S. operated 5 orbiters in this program, all of which went to the moon to image it in as much possible detail. By the end of the program, 90% of the moon's surface was imaged for the purpose of identifying landing spots for human missions as part of the Apollo project. By 1967, both the Soviets and Americans had now announced in some way, shape, or form their intentions to put humans on the surface of the moon, and both sides knew that comprehensive mapping would be ideal for getting down safely. Each of them had had their own successes and failures in landing robotic spacecraft and knew that knowledge of the environment was critical to success. Through the lunar program, the Soviets conducted mapping as well, but it was less systematic, and they relied heavily on images returned by the US missions or possibly gained through espionage. While mapping was important, something else that was needed to get to the moon was a big rocket. While individual spacecraft, even full rovers, were already doable, the ability to launch a spacecraft with 2 or more people, plus all of the supplies and scientific equipment they would need to get to the moon and back, required a new kind of rocket, what would be called a Heavy Launch Vehicle, or HLV. By September 1968, it was becoming evident that the Soviets were not having much success in building a rocket that would be capable of lifting a crewed spacecraft to the moon. Throughout 1969, the rocket failed spectacularly, blowing up on the launch pad each time a test was attempted. Using smaller rockets, the Soviets were successful in launching some of their prototype lunar crew capsules around the moon. Zond was the name of the crew capsule the Soviets designed to send humans to the moon. And while Zond 5 deserves credit for being the first spacecraft to fly to the moon and back to Earth, it was overshadowed by the much more ambitious Apollo program. Nevertheless, Zond 5 did carry living creatures, including 2 tortoises, a few plants, and even the eggs of a common household fruit fly. It was later revealed that Zond 5 was to have had a crew, but those plans were abandoned after previous Zond test missions showed that had cosmonauts been on board, they wouldn't have survived launch or re-entry. Ultimately, the death of Sergei Korolev, the unreliability of the Zond capsule to keep cosmonauts safe, and the lack of successful test launches for the HLV led the Soviets to canceling their plans to put humans on the moon. The Soviets instead turned back to robotic exploration and achieved something that was not to be duplicated until nearly 50 years later. On October 12, 1970, Luna 16 touched down in Mare Fecunditatis and collected 100 grams of lunar material. This material was placed in a capsule inside of a small rocket and launched back towards Earth. Upon its safe return, the sample would become the first entirely robotic return sample from another planet. Luna 20 and 24 would repeat the sample return feat, and it wouldn't be until 2020 and the success of the Chinese mission Chang'e 5 that another robotic sample return mission would be successful. In between their sample return missions, the Soviets also carried out the Luna 17 and Luna 21 missions, which carried the Lunokhod 1 and Lunokhod 2 rovers respectively. These were the first remotely controlled planetary rovers to land on another world. Lunokhod 1 operated for 322 days and traveled over 10 kilometers, while Lunokhod 2 operated for 120 days and traveled over 42 kilometers, a record for rovers that would not be surpassed until the 2010s in NASA Mars rovers. While the majority of the achievements were in the engineering of the missions, analysis from both the samples and the Lunokhod rover data allowed planetary scientists to begin to piece together the geological composition of the moon in much better detail. Over the next few decades, combined with the results from the Apollo program, planetary scientists would begin to formulate better theories for the formation of the moon, changes in the lunar surface over time, and the moon's relationship to the Earth. So, while the Soviets never did put humans on the moon, they did succeed in collecting samples via robotics and roving the surface of the moon, something their US counterparts have not done to this day.
A happy landing for Russia's unmanned Luna 17 spacecraft and a big step forward for Soviet scientists in Lenin's Jubilee year. The first self-propelled vehicle ever to drive across the lunar landscape is controlled from Earth. It's called Lunokhod 1, and here's how this extraordinary Heath Robinson 8-wheeler was rolled down from the spacecraft onto the Sea of Rains. The size of the vehicle hasn't been disclosed, but it's been sending back television pictures and carries, among other equipment, a laser reflector. It's been used to survey the moon's surface. So now Soviet space experts have proved their theory that space exploration can be carried out by automatic equipment without risking the lives of astronauts. To Russia, Lunokhod is worth its weight in moon dust.
So there we have it, the space race, or at least most of it or all of it, depending who you ask. We left out arguably the most important part, which is Apollo. That'll be next week. But Apollo, in some ways, is the end of the space race, or at least the beginning of the end. So I think everything that happens between 1957 and 1969 is really the core of the space race. Before we go, though, as a geographer, there's a few things I need you to think about. First, was it really a race? Who said so? Notice that at no point was there really any explicit exchange between Soviet and American leaders declaring a race. Really, the notion of it as a race came more so from their own internal communication to their populations through government propaganda and the news media. They both knew, of course, that the other side would see those things. Now, yes, many decision makers at the time were concerned about achieving certain technological feats before their evil counterparts, whether it be Soviets or Americans, but had the general public in any country not been constantly fed narratives of a space race, would they have come to that same conclusion? Did everyday people care about this stuff and think about it in the same competitive sense? As we'll see when we talk about the Apollo program, the answer is not really, but kinda. There was certainly a popular notion that dominated news and public messaging, but polling at the time reveals generational, class, gender, and race divisions in who was paying attention to the space race and who cared about it at all. Another thing to think about, second, is if it was a race, who won? I remember asking an American friend of mine who he thought won the space race. He confidently stated, of course, that it was the US because of Apollo 11 and the first moon landing. But as you may have seen in recent years, this perspective has been heavily criticized, even becoming a meme as a sort of retconning of Cold War history. Was the moon really the finish line? Something you might notice in the endless myriad of Cold War documentaries, books, and movies is the implication that putting humans on the moon was the ultimate goal of the space race all along. Hell, even I used the moon landing as a sort of framing device for this lecture and to separate this lecture from next week. But it's important to question that. There's a lot of evidence that there isn't a lot of evidence that there was wide-ranging support in the Soviet Union for putting humans on the moon, even in Soviet political circles. So what about all the other achievements the Soviets had other than the first moon landing? The Soviets had the first object in orbit, first living creature, first human in space, first multi-person crew, first docking, first object to leave Earth orbit, first object to contact the moon, first object to orbit the moon, first soft landing on the moon, first landing on Venus, first object to contact Mars, and tied to have the first orbiter around Mars. They also would go on to build the first modular space station and set countless records for long-duration human spaceflight. Now, the US also has a long list of firsts, but many of them are related to Mars or the outer solar system and take place in the 1970s, after the core portion of the space race. So, is it a case of the US getting somewhere and saying, we won the race was to here, and we got here first? Or is it a case of revisionist history when that is advocated? Did Soviet kids in the 70s, 80s, and 90s, when this stuff was still taught in schools, learn that they won the space race with Sputnik and Yuri Gagarin? A third thing I want you to think about, why was there a space race at all? This is a fundamentally geographical question, and one that geography is well suited to answer. Why not a medicine race or school race? Why not express technological superiority to your opponents by being the first country to cure cancer or have a 100% literacy rate? Why not race to world peace? The answer to why there was a space race at all, at least according to academics like Peter Dickens and James Ormerod, was that it was an exercise in power, specifically power over others and power of territory. And that comes uniquely from the technologies of war and space. We know rockets, of course, serve both. But in an ideological battle for domestic support in pursuit of global interventionism, notions of progress for all humankind were vital for justifying the investment in space and its related military technology, or vice versa. So fourth and finally, what did we learn? So last but not least, though literally last in terms of things that were considered important during the space race, is science. Luckily, if we wish, we can kind of cast aside everything I just talked about and just ask, did we learn a lot about the solar system during the space race? And thankfully, the answer is yes, absolutely yes. In this video, I didn't talk about much of the scientific advancements in our understanding of space, the moon, Mars, and even Venus during the space race, but we'll discuss each of those in future weeks when we look at those bodies respectively. We'll see how missions launched in the 60s and 70s did lead to scientific discovery, even if they were launched maybe for the wrong reasons. So overall, that's it, fellow patriots and comrades. Ultimately, for me, it doesn't really matter who won the space race, or if it was a race at all. But it is important who wants to call it a race and to what end, why, to justify what activities. That's the interesting part and the fun part of geography and studying space exploration. As for this course, let's move forward now to wrap up the space race by learning about Apollo, whether that was the end goal or not. And then finally leave all this competitive nonsense aside and learn about the flybys, orbiters, landers, and rovers that have helped us better understand our place in the solar system.